started.
So just a reminder, we do have that application quiz, quiz 1011 sitting out there that is due at noon tomorrow. So make sure that you are working on that. Does anybody have any questions that they want to ask on that? Anything you want me to go over on that quiz before we hit our new material for the day? Okay. Well then, today we're looking at units of capacity. But before I discuss capacity, I want to talk about the difference between volume and capacity. Volume is from length measurements. We've worked on volume. We calculated volume of several objects. And we found the volume, for example, a simple box, from length measurements. We might have this is 15 inches. This back here might be 10 inches and 8 inches. And the volume was a combination of those three measurements. We combined two of them first to get the area of a base, and then the third one to get that cubic measurement. So volume is cubic inches or cubic feet, cubic yards, cubic centimeters, cubic meters. It's a unit of length cubed. It's three length units multiplied together to make volume. Capacity is standard sized containers. Again, just like with our length, capacity was there to fit a need. And there were actually several different units that were developed to fit several different needs. Let's start out with one of our larger units, a gallon. A gallon was actually what you could hold in a standard men's hat. It was both for dry and liquid measure. You actually could hold water in a hat. They're waterproof. Now, we're not talking about like a cowboy hat. We're talking about like your dress style derby hats. Those were 1 gallon. You might hear a cowboy hat referred to as a 10-gallon hat. That obviously they don't hold 10 gallons. It was a sarcastic term because they were bigger than a regular hat. It was, oh, look, he's wearing a 10-gallon hat there. It was just kind of that mocking it. But that's where that term comes from. So smaller than a gallon, we have quarts. The term quart actually comes from the longer term quarter gallon. So that implies that there are 4 of them in a gallon. So these units were actually together because a quart was a gallon split into 4 pieces. It was a quarter of a gallon. Smaller than a quart, we have the pints. Now, the pint was a standard size container. It was a jar that could be used either for serving beverages, a pint of beer, pint of ale, whatever, or for storing and preserving food. They were just a standard size jar that was all over the place. The pint and the gallons were not originally linked in any way. We adjusted the size of the quart. A quart did not quite hold 2 pints, so we had to make the quart a little bit bigger in order to make them fit so 2 pints fit into it. So then the gallon got a little bigger. So the gallon that we use is actually quite a bit bigger than the historical gallon that came about from the men's hat. Now the pint was pretty much strictly a liquid measurement. It was fluids, beer, preserved food, vegetables usually had liquid in them, water in them to preserve them. Smaller than the pint, we have the cup. And there are now 2 pints in a cup. The cup has not changed in size hardly at all. The cup actually comes from the amount of powder for sugar, salt, whatever you can hold in your cupped hand, heaped up in a pile. A good friend of mine is a caterer, and I've measured. That's how she measures it. I've double checked her with a measuring cup several times, and she is almost dead on just with her cupped hand. Well, smaller than a cup, we have the fluid ounce. The fluid ounce actually is our one crossover to weight measurement. Fluid ounce was the size of 1 ounce of water. A cup is 8 fluid ounces. So obviously that was a liquid measurement. So now smaller than the fluid ounces, we get into the baking units. One fluid ounce contains 2 tablespoons. 1 tablespoon contains 3 teaspoons. Now, a little bit of a side note here on the abbreviations. Tablespoon can be abbreviated the way I did it with TBSP, or it can be a small TBSP. This is the only version of tablespoon that has a small t in it, but I've also seen it abbreviated capital TSP or just capital T. The most recent, most commonly used modern abbreviation is just the capital T. Whereas a teaspoon is a small t or a small TSP. So you can see the confusion there. TSP and just T are abbreviations from both of them. The only difference is a small t or a capital T. Trust me, if you have a recipe for chocolate chip cookies that calls for 3 tablespoons or 2 tablespoons of salt, and 2 teaspoons of salt, and you put in 2 tablespoons, I have not wasted a lot of cookie dough in my lifetime, but there's no amount of milk that makes those cookies go down. So, smaller than our teaspoon, we have units, and you don't need to know these units. I'm not going to test you on these. But I like throwing them out there to show that they are real units. And then the teaspoon, by the way, the tablespoon was your serving spoon that was used to eat. A fork was a more common utensil. A spoon was not real common, so a spoon was for soups or liquid foods. A little bit bigger than what we use as our standard eating spoon now would be what we would call a big spoon or a larger spoon. The teaspoon was actually smaller than what we use. It was a small spoon that was used for scooping sugar to put into your tea. So it was actually quite a bit smaller than what we think of as our average spoon. So neither one of those is actually what you'd see as your standard eating utensil of a spoon. Well, you probably heard the term a dash. 1 teaspoon contains 8 dashes. A dash, if you think of like a salt shaker or pepper shaker, it was our big spice shakers. You take that shaker and you tip it once, that was a dash. So 8 dashes, if you accumulated that up, was a teaspoon. Smaller than a dash. 1 dash contained 2 pinches. This again was spices or salt or whatever. You reached into it, you put your fingers together, and what was between your fingers went in. That was a pinch. 1 pinch contained 2 smidgens. This one always kind of grosses me out a little bit. You stick your finger into the spice or powder, and whatever sticks to your finger goes into the recipe. I'm always imagining the cook doing one of these to make it stick. I don't know. I shouldn't play in my own imagination, I guess. But those are, again, those bottom 3 are not ones you'll ever be tested on. But they actually do make measuring spoons. You can actually find measuring spoons for a dash, a pinch, and a smidgen. There are a lot of other units out there that we just don't see much anymore. One that you probably have heard of is a bushel. 1 bushel is 8 gallons. A peck. The old nursery rhyme, Peter Piper picked a peck of pickled peppers. A peck is 2 gallons. If you ever go to buy strawberries that are pre-picked and they come in the cardboard or the wooden trays, those are usually either 1 peck or 2 peck trays. So those are either 2 gallons or 4 gallons of strawberries. Same if you go to the orchard and buy apples. They usually have 1 peck or half a peck or 2 peck bags of apples you can buy. Most of the standard bag is usually a peck, which is 2 gallons. A barrel. A lot of people would throw out, when I ask them about a barrel, a lot of people say 55 gallons. Well, 55 gallons is actually a drum. A barrel is 31.5 gallons. This is your standard beer or whiskey keg. A half barrel is 15 3/4 gallons. Quarter barrel, 7 7/8. Now, there is a link between the capacity and volume, but not a very good one. If I want to link my capacity to my volume, 1 gallon, and I shouldn't even do equals, I should have actually a squiggly equal sign because it's not exact. It's approximately 231 cubic inches. The one that always surprises people is a cubic foot. If you think of a 5-gallon bucket, a lot of people look at that and say, well, that's about a cubic foot or maybe a little bit more than a cubic foot. It's actually considerably smaller. It's only about 2/3 of a cubic foot. A cubic foot, depending on how exact you want to be, some books go 7.48. I usually use 7.5 gallons is my conversion. A cubic foot's about 7.5 gallons. So I can use these if I would like to try to find the capacity for a tank, a cylindrical tank. It's 4 feet in diameter and 8 feet long, 8 feet from circle to circle. Find that volume. Remember, we start out with the area of the base. The base is that circle with a radius of 2 feet. So it's pi times 2 squared, or 12.56 square feet. So our volume, 12.56 square feet times 8 feet of length. That's going to be a volume of 100.48 cubic feet. If I want to convert that into gallons, now we have the tools to do it. Take my 100.48 cubic feet and put it over 1. I'll put cubic feet on bottom and gallons on top. 1 cubic foot is 7.5 gallons. It's 753.6 gallons. That's assuming that the measurements we had are the inside of the container, not the outside. So that's about a 750 gallon tank. In the metric system, as we mentioned, the metric system was a planned system, a created system. It was thought out. One of the things that's awkward in the standard measuring system are these conversions here. There is no real link between volume and capacity. We just had to measure them as close as we could and come up with those equivalencies. They're approximate. Both of them are, actually. So in the metric system, they wanted to avoid that approximate conversion, and they wanted it to not be so awkward. 231 cubic inches in a gallon, that's a tough number to remember. So they actually, when they created the unit of capacity in the metric system, they based it off a unit of length. So the unit of capacity we use in the metric system is a liter. It's abbreviated with an L. Now, I was always taught that the liter had to be abbreviated with a capital L. I found out years later that the reason for that was not really that it had to be abbreviated with a capital L. It was just, it can be tough to distinguish between an L and a 1, a small L and a 1. In fact, on a lot of your older typewriters, the keyboards didn't have a 1 key. You actually used the small L for a 1. In fact, many of your older type fonts, the 1 and the small L were indistinguishable. Well, with modern type fonts, there is a difference, so it is okay. But you'll see, if I use the small L, you look at that, is that a 51 or is that 5 liters? Using a capital L makes it obvious. So I will pretty much always use the capital L just because that's what I'm used to, but it's not a necessity anymore. So going smaller than a liter, of course, we have the deciliter, centiliter, and milliliter. Milliliter being 1,000th of a liter. Of course, we skip 10,000, 100,000. We go to microliter is 1,000,000th of a liter. Bigger than a liter, we had a decaliter, hectoliter, and a kiloliter. A kiloliter is about 260 gallons. We don't use that for much of anything. That's a little bit bigger than what we need for most things. So just like with our length measurements, we use our main unit a lot. You use milli a lot. Kilos, sort of, but not so much. We do actually use a deciliter. Any of you that have ever done any EMT training or medical training, a deciliter is the basis of all your blood and other tests. You're doing a blood sugar test, and your blood sugar comes back at a 95. That's 95 milligrams of glucose per deciliter of blood. Or your cholesterol test comes back at like a 168. That's 168, again, milligrams of cholesterol per deciliter of blood. Well, when they planned this out to make things work, they decided that 1 milliliter was going to equal 1 centimeter cubed. In other words, 1 centimeter by 1 centimeter by 1 centimeter. That's a milliliter. So about the size, maybe slightly bigger than a sugar cube, is a milliliter. So if we are looking at volumes and we want to convert to a capacity in the metric system, it's pretty straightforward. Let's say we have this tank here that is, let's go 2.5 meters this way, 1.5 meter this way and 1 meter this way. I want to figure out how many liters are in that. I first find my volume, my area of my base here. If I treat that bottom as my base, the 2.5 meters times 1.5 meter, which is 3.75 meters squared. So the volume is the 3.75 meters squared times 1 meter of height, or 3.75 meters cubed. Now our conversion here is from cubic centimeters to milliliters. So I need to change that to cubic centimeters. 3.75 meters cubed going into centimeters cubed. To get from meters to centimeters on my chart, it's 2 spots to the right. But these are not centimeters and meters, these are centimeters cubed and meters cubed. So 2 spots on the chart, each spot on the chart is 3 decimal places. So 2 spots on the chart is 6 decimal places. So we go 1, 2, 3, add a 0, add zeros for 4, 5, and 6. That's 3,750,000 cubic centimeters, which is also 3,750,000 milliliters, since 1 milliliter was equivalent to a cubic centimeter. So now to take that 3,750,000 milliliters and convert it back into liters. Well, similar chart, liters are in the middle. Milliliters are off to the right. Prefixes are all the same. Get from milliliters to liters is 3 spots back to the left. So move our decimal point 3 spots back to the left. That is 3,750 milliliters. Or sorry, 3,750 liters is the capacity of that tank. It's not quite a 1,000-gallon tank. There is a conversion between our metric and standard. 1 gallon is about 3.785 or 3.79, however you want to round it, liters. So you can see that 3,750, not quite 1,000 of those. So your current gas tank, if you have an 18-gallon tank, one gallon is 3.785 liters. Gallons cancel out. You have 18 times 3.785. That's going to become a 68-liter tank. Okay, well, we're done a little bit early today because I had anticipated some questions on the quiz, so we'll get you to the homework here right now. The homework is out of the big book. There's a few pages here anyway, so page 302, exercise 8-9. Page 303, exercise 8-10. Page 325, exercise 9-11. And page 326, exercise 9-12. So I'll let you guys have the last 23 minutes here or so to get started on homework. Otherwise, I realize since you guys are working from home, if you would like to get moving, if you'd like